Hello students, welcome. Today we want to do the third chapter of Form 3 work, which is Organic Chemistry 1. So we are going to do lesson 1 and we want to start by defining the term organic chemistry. So we are saying organic chemistry is the study of carbon compounds excluding dioxides, carbonates and also hydrogen carbonate. So next we are saying carbon forms a very large number of compounds, and this is because carbon atoms form stable covalent bonds with the other carbon atoms and with atoms of other elements. And this is due to the fact that carbon uses all its valence electrons to form 4 covalent bonds with the carbon atoms and with atoms of other elements. Number 2, we are saying carbon forms single, double and triple bond with other carbon atoms. For example, we can have carbon bonding with another carbon using a single strong covalent bonds, or we can see carbon bonding with another carbon and in between the two carbon atoms we have a double bond, and we can see carbon bonding with another carbon using triple bond. So that's why we are saying carbon forms single, double and triple bonds with other carbon atoms. Then the last we are saying carbon atoms can join each other to form long chains. So this 3 reason is why carbon usually forms large number of compounds. So we are saying note the property of an element where its atoms can bond with each other is called catenation. So we are saying the property of an element where its atoms can bond with each other is called catenation. So we are saying this chapter mainly deals with a group of compounds called hydrocarbons. So let's know the definition of hydrocarbons. What are hydrocarbons? We are saying hydrocarbons are compounds which are made up of carbon and hydrogen atoms only. Even from the look at the word hydrocarbons, it's having hydro, which is from hydrogen, and also carbon. So we're saying hydrocarbons are compounds which are made up of carbon and hydrogen atoms only. So we're saying hydrocarbons are classified into 3 groups depending on the type of bond that exists between individual carbon atoms in a molecule. These groups are, the first one is called alkanes, the next one is called alkenes, then the last one is called alkynes. So if you check, the difference is in alkanes we have either. When we're dealing with the alkenes we have either. Then when we are dealing with the alkynes we have y there. So check the letter that you have written in italics. So when we're having alkane, in between two individual carbon atoms we have single bond in alkanes. So when we're talking about alkenes, in between 2 carbon atoms we have double bond. Then when we're dealing with alkynes, in between 2 carbon atoms we have triple bond. So that's why we are saying hydrocarbons are classified into 3 groups or 3 categories depending on the type of bond that exists between individual carbon atoms in a molecule. So if between individual carbon atoms we have only single bond, that group of hydrocarbon is called alkanes. So if we have double bond in between 2 individual carbon atoms in a molecule, what we are talking about will be alkenes. So if we have triple bond in between 2 individual carbon atoms in a molecule, the hydrocarbon or the group of hydrocarbon we are talking about is called alkynes. So let's go next. We go saturated and unsaturated hydrocarbons. So let's start with what are saturated hydrocarbons. We're saying this is a hydrocarbon in which only single covalent bonds are present in the molecules. Example of saturated hydrocarbon is alkanes. And if you check, in between 2 carbon atoms we have only single bond, or we're having only single bond bonding with other carbon atoms and with atoms of other elements. So let's proceed to the second, that's unsaturated hydrocarbons. So what are unsaturated hydrocarbons? We are saying these are hydrocarbons, or is a hydrocarbon which contain at least a double bond when we're talking about alkenes, or triple bond when we're talking about alkynes in between two carbon atoms in a molecule. So examples of unsaturated hydrocarbons are alkenes and also alkynes. So when we check here, we have alkenes. So this will be alkenes. So here is not A, it is E, alkenes. So when you're dealing with alkenes, in between two carbon atoms, we have a double bond. So that's why it is unsaturated hydrocarbons. So when we talk about alkynes, in between two carbon atoms, we have a triple bond. So we are saying examples of unsaturated hydrocarbons include or are alkenes and also alkynes. So in alkenes, we have a double bond. In alkynes, we have triple bond. So next, let's go and see something called homologous series of organic compounds. So let's start by defining what homologous series is. And we are saying homologous series is a group of compounds with similar chemical properties, chemical formula, and they exhibit a steady gradual change in physical properties. So let's go and see examples of homologous series include: 1. We have alkanes, alkenes, alkynes, alkanols, and we have alkanoic acid. So when we are dealing with organic chemistry 1, only we are going to do with alkanes, alkenes, and also alkynes. In other words, we are going to do the 3 hydrocarbons. So when we go to Form 4, Organic Chemistry 2, we will be doing alkanols and also alkanoic acid there. So let us see the general characteristics of homologous series. So that means all these homologous series that we have listed there, the 5, all of them, they have all these general characteristics. So we are saying number 1, they can be represented by a common formula. They can be represented by a common formula. For example, if we are dealing with the alkanes, so we are having the general formula of CnH2n plus 2, and where N is the number of carbon atoms in a molecule. So if we are dealing with the alkene, maybe the formula will be CnH2n, and where N is the number of carbon atoms. If we are dealing with the alkynes, which we are going to do in Organic Chemistry 1, the formula will be CnH2n minus 2, where N is the number of carbon atoms. So what we are going to say is, number 1, the general characteristics is they can be represented by a common general formula. So number 2, each member differ from the next by CH2 in molecular formula. Number 3, we are saying all members show similar chemical properties. Number 4, we are saying the physical properties of the members change gradually along the series. Then number 5, we are saying the general methods of preparation can be applied to any member of the series. Those are the general characteristics of homologous series. So next we are going to say all homologous series have similar prefix indicating the number of carbon atoms. For example, if we see the prefix of meth stands for number of carbon atoms, which is 1. Eth stands for 2 carbon atoms. Prop stands for 3 carbon atoms. But stands for 4 carbon atoms. Bent stands for 5 carbon atoms. Hex stands for 6 number of carbon atoms. Hept stands for 7 number of carbon atoms. Oct stands for 8 number of carbon atoms. Non stands for 9 number of carbon atoms. Then dec stands for 10 number of carbon atoms. So this is the prefix and the number of carbons that they stand for. So we go next, functional groups, and we are saying we start with, first of all, knowing what is a functional group. So we are saying functional group is a group of atoms or a bond in homologous series which determine the chemical properties of the group members. So examples of the functional groups, we see the organic compound. So when we're talking about organic compound, even hydrocarbons will be under the organic compounds. So we're having alkanes, alkynes, which we are going to learn in organic chemistry 1, and also alkanol and also alkanoic acid. So let's see the suffix or the suffix for this organic compound. When we're having alkanes, we check the last 3 letters. So that's A and E. When we're dealing with alkene, the last, those 3, E and E. Then when we're talking about alkyne, it will be Y and E. Then when we're talking about alkanol or alkanols, we are going to have OL. Then when we're talking about alkanoic acid, it will be OIC, like that. So we are going to have the suffix here. This is for alkanes, alkenes, alkynes, alkanols, and also alkanoic acid. So let's go and see the functional groups. When we're talking about alkanes, they have no functional group. They have no functional groups. So when we're talking about alkenes, we have double bond as their functional group. When we're talking about alkyne, we have a triple bond as their functional group. When we're talking about alkanol, they have hydroxyl group as their functional group. When we're talking about alkanoic acid, we have this COOH, that's carboxylic group, as their functional group. So next we are going to proceed and see the first class of hydrocarbon, that's alkenes. So I want to start first of all by knowing what are alkenes. So we're saying alkenes are a group of hydrocarbons whose carbon atoms are linked by single covalent bonds. And we're saying hydrocarbons in which only single covalent bonds are present in a molecule are said to be saturated. So during the exam, we can be asked a question of explain why alkanes are said to be saturated hydrocarbons. So we can say the answer, this is because all the carbon atoms in alkanes are linked by single covalent bonds. Yeah, that's what we can answer. So we go next and see sources of alkanes. Where can we get alkanes? So we're saying alkanes occur naturally as natural gas, that's the first source, biogas, and also in crude oil. So we have 3 natural sources of alkanes: natural gas, biogas, and also crude oil. So we start with natural gas. We are saying natural gas is a mixture of methane, ethane, propane, and also butane. Remember we said the suffix for alkanes is A and E. So if you check all this name, methane, ethane, propane, and butane, all of them, they end with A and E. And remember, we have seen the prefix and what number of carbon atoms they stand for. And we said meth stand for 1 carbon atom, eth stand for 2 carbon atom, prop stand for 3 carbon atoms, then we said but stands for 4 carbon atoms. So that means these are the first 4 members of the alkane series. So we are saying natural gas is a mixture of methane, ethane, propane, and butane, with methane forming 80% of its composition. That means when we're talking about natural gas, the main component of natural gas is methane because it forms 80% of its composition by mass. So next we are saying methane forms about 6 to 75% biogas biomass, with other gaseous alkanes, that's ethane, propane, and butane, forming the remaining 40 to 25%. So we proceed to the crude oil. We are saying crude oil is the major natural source of alkanes. So we said we have 3 sources of alkanes. One of them is natural gas, biogas, and crude oil. So out of the 3, we are saying crude oil to be the main source or the major natural source of alkanes. We are saying it contains a range of alkanes which can be separated into various components by fractional distillation. And the reason why is this is due to the fact that the different components of alkanes, they have close but different boiling points. Because of this reason, they can be separated by fractional distillation. So let's go and see next. We want to see the following. The following are the steps involved during fractional distillation. The first step will be removal of suspended solids from through filtration. Number 2, crude oil is pumped into furnace and heated to about 400 degrees Celsius to vapor it. Then we are saying step 3, the hot vapor is directed to a fractionating column, and the column contains perforated horizontal plates. So this is the what we are going to do in fractional distillation of crude oil. We're having the crude oil in a round bottom flask, we're heating it. So that means we're having the thermometer there to measure the temperature, and we have the glass speed to increase the surface area for condensation. And here we're having ice cooled water here, and this is the distillate collected thereafter. So let's see the fractionating column. This is how it look like, and we're saying note, an ordinary thermometer of 0 to 110 degrees Celsius should not be used because it will break due to the high temperatures. So let's proceed and see. We're saying the fractions obtained have various uses as shown below. So the fractions obtained in fractional distillation or during fractional distillation of crude oil, here the first column we have number of carbon atoms per molecule, second column we have the boiling point in degrees Celsius, then the third column we have fraction product, and the fifth column we have uses of the fraction. So we start with the number of carbon atom 1 to 4. They will be distilled off at a boiling point below 25 degrees Celsius, and the name of the fraction product is called refinery gases. So what are the uses of the refinery gases? It has two uses. Number 1, they're used as laboratory gas, and number 2, they're used domestic gas cookers. So we are having a number of carbon of 4 to 12. They will be boiling or distilled off as the second fraction in between a boiling point of 40 to 100 degrees Celsius, and it's called gasoline. That's the fraction product, gasoline. Then, or you can say petrol. So what is the use of petrols? They're used to fuel in petrol engines. So we go number of carbon atom of 7 to 14. They will be distilled off at a temperature range between 90 to 150 degrees Celsius, and the name of that product or fraction product is called naphtha. And the use of that fraction is used to make chemicals. Then we're having carbon atoms of 9 to 16. They will be distilled off at a temperature of between 150 to 240 degrees Celsius. The name of fraction product is called kerosene or paraffin. And the use of that kerosene or paraffin is they are used to fuel jets or aeroplanes, and they're used domestic uses. So we're having carbon number 15 to carbon number 25. They will be distilled off at a temperature range between 220 to 350 degrees Celsius, and the name of fraction product is called diesel. So what is the use of diesel? It's used to fuel diesel engines. So let's proceed and see. We see number of carbon atoms of between 20 to 70. We're having it will be distilled off at a temperature range between 255 degrees Celsius to 350 degrees Celsius, and the name of fraction product is called lubricating oil. So what is the use of lubricating oil? Used to lubricate engine parts in order to reduce friction. Then lastly, over 70 carbon atoms, they will be distilled off at a temperature of above 350 degrees Celsius, and the name of that fraction product is called residue or bitumen, and it has two uses. One, it's used in road construction or road servicing or road tarmacking. Then the second use is used on roofs of houses as it is waterproof. Then I say note, the fractions obtained are not very pure because some hydrocarbons are found in more than one fractions. For example, if we check here, number of carbon atoms 15 to 25, the name of fraction product is called diesel. But this fraction is also obtained here in lubricating oil because the number of carbon atoms here, it is in between 20 to 70 number of carbon atoms. But 20, 21 and 22, which are in lubricating oil, they are also found in the diesel fraction product. So that means we're having some fractions which are found in more than, some hydrocarbons which are found in more than one fraction. So we're saying, therefore, a more efficient fractionating column can be used to improve the separation. So next we are going to go and see cracking of alkanes. So start first of all, what is cracking? So we're saying cracking is the process whereby long chain alkanes are broken up into smaller and more useful alkanes, such as alkenes and also hydrogen gas. So we have general equation for the cracking process, and that's long chain alkane. They will be heated in a temperature of between 400 to 700 degrees Celsius, and we are going to obtain smaller chain alkanes. We are going to get alkene and also hydrogen gas. So we're saying here the reason why we are going to crack long chain alkane is that there is a low demand for the long chain alkanes, especially those with more than 8 carbon atoms or more. So we are saying short chain alkanes or smaller chain alkanes are the ones that are in high demand. So to increase the supply of the short chain alkanes which are in high demand, we have to break down the long chain alkanes in a process known as cracking of alkanes. So let's go and see examples of cracking of alkanes. So we're having here, this is propane. We're having propane, 2 moles of propane. They're heated in a temperature of between 600 degrees Celsius to 700 degrees Celsius to form methane gas, which is a shorter chain alkanes. We are going to get ethene, which is an alkene. We are going to get propene, which is also an alkene, and also hydrogen gas. So here, when you see during cracking of this propane alkane, we are going to get a short alkane, which is methane, and also 2 alkenes and also hydrogen gas. But we can have again a long chain alkane, that's here in this case heptane. This is called heptane. It's C7, that's the molecular formula, H16, which is a liquid. When it is heated, we can get propane, which is a shorter chain alkane, and also we're having here butene. So that means there's no hydrogen gas. So that means during the exam you may see an equation where it doesn't have plus hydrogen gas. So don't say this process or this type of reaction is not cracking. It's not cracking process. So during cracking, hydrogen may be produced or may not be produced. So we're having 2 types of cracking. Let's go and see the types of cracking. We're having 2 types of cracking. One is called catalytic cracking, the other one is called thermal cracking. So catalytic cracking occurs at relatively low temperatures and involves heating the long chain alkanes in the presence of a catalyst and at low pressure. The catalyst used is silicates, or we can have a mixture of bonded alumina and also silica. So number 2, we can see thermal cracking. It occurs at a very high temperature of between 400 degrees Celsius to 700 degrees Celsius and only involves heating the long chain alkanes. So if we're having these 2 types of cracking, which one is a better? Which one can be better used? So we're saying catalytic cracking is better than thermal cracking. Reason? Because catalytic cracking is achieved at low temperatures and pressure, hence more economical when compared to thermal cracking, as less fuel is used when we are dealing with catalytic cracking. Let's see the importance of cracking or advantage of cracking. So number 1, we said it breaks long chain alkanes which are in a low demand to shorter chain or smaller chain alkanes which are in a high demand or which are more useful. So number 2, we're saying it's a source of hydrogen gas and also alkenes. So if you want to get source of alkane, I mean a source of alkene, or you want a source of hydrogen gas, you can obtain it from cracking process. So that's an advantage of cracking process. So that's the end of our video today. Thank you.